So my name's Joe Suma. I'm with Belden and with Precision Optical Technologies Advanced Development Group. So what we're showing today is the XGS-PON Extender, right? This is a proof of concept from Belden, right? This was developed in Rochester with our Advanced Development Group from Precision Optical Technologies. Specifically, we're looking at that 1RU unit. That's the XGS-PON Extender, all right? So what that's doing is illustrated on the slide above here. The typical use case for XGS-PON that we're showing here is 20 kilometers of fiber and a 1x64 splitter, right? So that has a loss budget. That's loss budget limited to 20 kilometers. What this device allows us to do is basically using a proprietary amplification technique, boost that power level by another 16 dB, all right? And what that enables is basically the system network designer to use that 16 dB of gain in any way they choose, right? So our use case that we're demonstrating today is that same 1x64 splitter is now going through 65 kilometers of fiber, all right? And everything else in this system is basically stock, normal equipment. We're using N2 optics, which are typical. They're not even the high-range optics that are available. We're using a stock OLT, and this is a typical ONT that would be in anybody's house or business, all right? So by just adding this network component, we've extended the range another 45 kilometers. Or as the use case is showing up here, you can take that additional 16 dB of budget and either make your network implementation more dense. You can so go to a 128 splitter, or and go a shorter distance. Or in the case there, to the far right, we're using a 1x32 splitter and going 75 kilometers. So basically, as a network designer, this is a tool that gives you that type of flexibility. So you can reach out to either, well, more customers in different ways, right? You can go a higher density network at a certain distance, or you could extend your reach basically wherever you need to go. You can just insert this into your network, right? This is not data aware, right? You don't need special software on the OLT or on the ONT. Put it in the network. The network designer has that freedom to use it as they wish, right? So just taking you through the individual components here. Like I said, this is OLT. We're just going directly from the OLT into the PON extender, right? From the PON extender through 65 kilometers of fiber, right? If you go to our OpenPath software, you can see it's recognizing now the ONT at transmit power of about 7 dBm and OLT receive power of minus 18, 19. Definitely in a stable, happy level, right? So, so the network is up and running in a very stable state. In fact, if you look at our test set here, we've been running since we started up this morning, which is 5 hours and 15 minutes ago. We have 0 errors. We're doing 65 kilometers without any issues. As a network component, just the challenge we're trying what we're trying to achieve is amplification above both upstream and downstream, right? The downstream, so from the OLT through the network, is the easy part because you've got very high signal level, low noise at the downstream amplification, so that's easy to deal with. Coming back through the network is what the real challenge is, and what the real novelty of this device is, that you now have this device that's literally sitting in someone's home or business, that is not a specialized device to achieve 65 kilometers of distance. So for this to reach back and pull that data out at a reasonable signal to noise level is the real challenge of this, and really what the reason this technology isn't available right now. All right, right now, if you want to extend your PON, your passive network, you add active elements. You either put in a remote OLT or you put a repeater in the line, both of which require, well, the remote OLT is significant expense, regulatory cost, time. By just putting this in the CO, where basically you have your maintenance people, everyone's there, right? And the rest of the network is completely passive, right? It's a tremendous advantage from a cost of ownership perspective. There's no truck rolls to be had unless you have a fiber break, which is going to be true for everything, right? Right. So being able to handle the downstream at a reasonable signal to noise level, keep everything in the actual passive network actually passive is really what makes this device unique of what's available right now.